The sun, our life-giving star, is also becoming an increasingly disruptive force in modern space technology. As solar activity ramps up towards its peak, a phenomenon known as the solar maximum, scientists are observing significant effects on the Earth's upper atmosphere. One of the most noticeable consequences is the premature aging and degradation of low Earth orbit (LEO) satellites, most notably SpaceX's ambitious Starlink constellation. With over 5,000 satellites already deployed and thousands more planned, understanding this solar spacecraft interaction is more critical than ever. What is happening? Recent observations and scientific reports have revealed that powerful solar storms, caused by solar flares and coronal mass ejections (CMEs), are heating Earth's upper atmosphere. This heating leads to a phenomenon called atmospheric swelling or expansion. When this happens, the density of the upper atmosphere increases, which results in higher aerodynamic drag on satellites in LEO. For satellites like Starlink, which orbit at altitudes of around 550 kilometers, this increase in drag means they must work harder to stay in orbit. More fuel is used for orbit maintenance, reducing satellite lifespan and efficiency. In some extreme cases, if a satellite cannot correct its trajectory in time, it may re-enter the Earth's atmosphere and burn up prematurely. Why is this happening now? The Sun undergoes an approximately 11-year solar cycle. During the solar maximum, solar activity, including flares, CMEs, and solar wind, reaches its peak. The current cycle, solar cycle 25, is predicted to peak between 2025 and 2026, and scientists have already observed stronger than expected solar events. These solar events inject high amounts of energy into Earth's thermosphere, the layer of the atmosphere that starts around 80 kilometers and extends up to 600 kilometers or more, causing it to expand and increase in density. The result is a drag force acting on satellites, similar to how air resistance slows down a car, but on a much more complex and subtle scale. Impact on Starlink and other LEO satellites. SpaceX's Starlink satellites, being in relatively low orbits, are especially vulnerable. In February 2022, a geomagnetic storm caused by solar activity led to the failure of at least 40 Starlink satellites shortly after launch. The satellites experienced higher than expected drag and were unable to reach their designated orbits, resulting in controlled atmospheric re-entry. This incident wasn't isolated, it was a wake-up call for the satellite industry. The more Starlink satellites are launched, the more urgent it becomes to adapt to the growing threat of space weather. With over 12,000 Starlink satellites planned in total, and potentially up to 42,000, even small changes in the atmospheric environment could lead to significant operational and financial consequences. Is there a silver lining? Interestingly, there is a potential benefit to this solar-induced atmospheric swelling, the natural deorbiting of defunct satellites. In space, debris from dead satellites and leftover rocket parts poses a serious threat to operational spacecraft. If solar activity helps remove these dead objects faster, it could reduce long-term space debris. However, this benefit is outweighed by the risk it poses to active satellites. Increased drag can lead to unplanned deorbiting, collisions, or service outages, especially if satellites are not designed with sufficient propellant or automated orbit correction capabilities. Broader concerns. The resilience of mega-constellations. The rapid deployment of mega-constellations like Starlink, Amazon's Project Kuiper, and OneWeb raises questions about their resilience. These constellations rely on hundreds or thousands of satellites working in unison to provide global internet coverage. If a significant number of these satellites experience disruptions simultaneously due to a solar event, the consequences could be widespread service interruptions, data loss, or communication failures in underserved regions that rely heavily on satellite internet. Moreover, mass satellite failures can lead to a chain reaction known as the Kessler syndrome, where one satellite's breakup causes debris that damages others, leading to a cascading effect. Solar storms, therefore, add another layer of unpredictability to this already delicate orbital ecosystem. What can be done? 1. Improved forecasting. Agencies like NASA and NOAA are investing in solar weather forecasting tools to predict solar storms more accurately. The earlier satellite operators can be warned, the better they can prepare. 2. Stronger design standards. Satellites may need to be built with greater shielding and enhanced thruster systems to counteract the drag. This could mean higher costs but also longer service life and resilience. 3. Orbital altitude adjustment. Operators could temporarily raise the altitude of satellites during peak solar activity, though this is a fuel-intensive operation and not always viable. 4. International collaboration. The global nature of satellite infrastructure requires international coordination for monitoring space weather, sharing data, and managing responses to major solar events. Looking ahead, as humanity becomes more dependent on space-based services for communication, navigation, defense, and Earth observation, our vulnerability to solar activity becomes more apparent. The rise of mega-constellations magnifies this vulnerability, making it crucial to prioritize space weather research and satellite resilience planning. SpaceX and other companies must adapt quickly, incorporating real-time solar weather data into satellite operation protocols and investing in more robust engineering solutions. Governments, too, have a role to play in regulating the deployment and management of satellites in a way that considers long-term orbital sustainability. The sun, a source of life and light, is also an unpredictable force that now threatens one of humanity's most advanced technological achievements, global satellite networks. The ongoing expansion of constellations like Starlink brings both opportunity and risk. As we edge closer to the peak of solar cycle 25, it is clear that space weather is not just a scientific curiosity, it's a major operational challenge. Understanding, preparing for, and mitigating the impact of solar storms on satellite infrastructure will be essential in ensuring that the future of global connectivity remains stable and secure, even under the stormy gaze of our nearest star.